Hello, welcome to the lesson video for lesson 6, module 4. This starts on page 32. There's a lot to cover and I want to make sure we fit it all in, so you're going to hear me rushing through this a little bit. You'll notice I've already highlighted a couple things in this and added some things, so I'll explain what those are when I get to them. All right, so this is all about solving basic one variable quadratic equations. So a physics teacher puts a ball at the top of a ramp. You can see the picture here, and the ball rolls down. The class determined that the height of the ball could be represented by the equation h equals negative 16 t squared plus 4, where the height, h, is measured in feet, and t is the time in seconds. So this is a standard form of a quadratic equation. Y equals ax squared plus bx plus c. What do you notice about the structure of the quadratic expression in this problem? It's very similar, except for there's a middle term that is missing. Obviously, we also have a negative coefficient for a. So let me identify these parts really quick, and I'll color code everything. So this ax squared, that is the quadratic term. I'll just abbreviate quad term. And then the middle term plus bx is often referred to as the linear term. You notice there's no exponent there. And the quadratic term is because there's an exponent of 2. And then plus c, this is the constant. So the big idea with this lesson, with this particular concept, is when you notice that it's in a certain form, these quadratic equations, solving them is you're going to see a familiarity with how they're solved. So in the equation, explain what the 4 represents. So plus 4, the constant. Essentially, that is, and this happens a lot with the real world examples that they give you. Actually, let me use a nice bright red here. That is the starting height of the ball at the top of the ramp. In other words, if I were to put 0 in for the time, I'd get h equals 4, because 0 squared times is 0, 0 times negative 16. So if I plugged in 0, I'd get h equals 4. Remember, h is the height in feet. So it starts at 4 feet above the ground. Okay? Explain how you would use the equation to determine the time it takes the ball to reach the floor. When it gets to the floor, the height is going to be 0. So let h equal 0. So now we're going to actually go ahead and solve it. So 0 equals negative 16 t squared plus 4. I'm actually going to add the 16t squared to both sides, so I get rid of that negative. And I end up with 16t squared equals 4. I'm going to divide both sides by 16. Let me move this up over here. So the 16s, switch color, cancel each other out. T squared equals 4 over 16, but I can simplify that. If you were to put that in your calculator, you'll get 1/4. Now, we are not done. We need to know what t is. How do you do that? Well, you undo squaring something by taking the square root. So when I do that, the square root of 1/4 is you'll see is 1/2. Technically, it's either positive 1/2 or negative 1/2, because uh, positive 1/2 times 1/2 is 1/4, and negative 1/2 times negative 1/2 is 1/4. Because remember, a negative times a negative is a positive. So something you need to be aware of moving forward: when you take a square root of a positive number, it is either a positive or a negative answer. Now, here is the issue with this. When we get to the next question, now consider the two solutions for t. Which one is reasonable? Is positive 1/2 seconds or negative 1/2 seconds reasonable? So here is the big idea with these word problems, these real world problems, is that sometimes they cannot be a negative, or sometimes it's not reasonable for it to be a positive. So I'm going to add this here in blue. Cannot be a negative. A negative. Time should not be a negative number. It's not always the case, but usually. So my final answer then, that makes sense for this problem, is t equals 1/2 seconds. All right, I'm going to pause the recording here and move to the next problem. Okay, to try to save a little time, I got a head start on setting some of this up. So you might want to pause the recording so you can copy this down. I'm going to read this quickly. Lord Byron is designing a set of square garden plots so some peasant families in his kingdom can grow vegetables. The minimum size for a plot recommended for a vegetable garden is at least 2 meters on each side. Lord Byron has enough space around the castle to make bigger plots. We don't know how much bigger. So he decides that each side should be a minimum of 2 meters plus an additional X meters. So that's where the X plus 2 comes from. So the first task is, what expression can be used to represent the area? So an expression is does not have an equal sign. So this is an expression. And the next one, it's talking about 12 families are interested in growing vegetables. So what equation could be used to find the area? So A equals, so I multiplied my expression by 12 to get the answer. So C, if the total area available for the garden is 300 square meters, what are the dimensions of each garden? So I'm going to set this up and then pause the recording. So I'm going to replace A with 300 and put that equal to the rest of my equation. So try solving this on your own. I'm going to pause the recording. You pause the video. And in a moment, when we come back, we'll see some of the work to solve it. Okay, now we're back. So you'll notice some of the things that I wrote down to help you with this, besides the solution. Off to the left, I wrote PEMDAS and then the arrow going backwards. Something that another teacher in a different video did was something he calls SAD-MEP. I'm not sure if I'm a big fan of it, but I prefer PEMDAS in reverse order, whatever helps you remember it. But when we're solving equations, basically you're going backwards in the order of operations. Problem is, it's not always that way. So how do you know? Practice, get good at it, and then you'll learn. So first step, I divided both sides by 12. That's in blue. 12s cancel. Then to undo the X plus 2 squared, I took the square root of both sides. Now remember, the square root of 25 is positive 5 or negative 5. So that's how I got this answer, X plus 2 equals 5, or X plus 2 equals negative 5. So basically, I've got two equations to solve. Now, when I solve them, I get X equals 3 or X equals negative 7. If this wasn't a word problem, there would be two answers, and that would be it. But when I look at the last part, what value of x does Lord Byron need to add to the 2 meters? What would make sense? Would a -7 for our additional plot of land make sense? No. 3 makes sense because negative doesn't make sense. So let me put a star here. Negative does not make sense. So not make sense for this word problem. That's usually how it is, but not always. So be careful. So x equals 3. I'll put a label meters. So that is the additional amount. Okay, I'm going to pause the recording. We'll go to the next page. Okay, we're running out of time, so I'm going to move quickly here. I'm going to start each one of these. We're going to solve each of these 4 problems, and then we're going to go on the next page and do number 6 quickly. All right, so you can see I already started number 1, added 9 to both sides. Then at the next step, I divided both sides by 3, and now I get x squared equals 9 divided by 3 is 3. Now, to undo x squared, I'm going to take the square root. Now, here's the problem. Oh, some of them may be radicals in their solution. Radical is the square root symbol, okay? So the answers, there's 2 of them for this, is x equals positive radical 3. That's another way to say square root. Or negative radical 3. Another way to do that is just to put plus or minus radical 3. So either of these are acceptable ways to answer this problem. Okay, see if you can set up number 2 on your own. I'm going to pause the recording and fill in the information. Okay, so first step for number 2 is to take the square root of both sides. I get x minus 3 equals positive or negative 1. So I set up 2 different equations, and I'm going to add 3 to both sides. On this side, I get x is equal to 4, and x minus 3 equals negative 1. I'm going to add 3 to both sides, and I get x is equal to 2. So the answer is x equals 4 or 2. Okay. So first step for number 3 is to divide both sides by 4, then take the square root. Again, I'm going to pause the recording. When we come back, you'll see some of the work laid out for you. Okay, we're back. So after doing the first step of dividing both sides by 4, I'm going to take the square root of both sides. That makes this just x minus 3, which is nice. And then on the other side, we get positive or negative 1/2. The square root of 1/4 is 1/2. Don't believe me? Check it on your calculator. So that means we have 2 equations. X minus 3 equals 1/2, positive 1/2, or x minus 3 equals negative 1/2. Again, add 3 to both sides. I'm kind of setting this all up as solving them both at the same time. So x is equal to 3.5, or x is equal to, be careful, negative 1/2 plus 3 is 2.5. And that is my 2 possible answers for this one. Okay, I'm going to pause the recording, see if you can do all of number 4 on your own, and then compare your answer with mine. First step, divide both sides by 2. Okay, so here were the steps that I did. After I divided both sides by 2, I got x minus 3 squared equals 6. I take the square root of both sides. X minus 3 equals plus or minus the radical 6, or the square root of 6. Then I split it into 2 problems. Add 3 to both sides. And these are your final answers. Notice they are radical signs in the final answers. So it looks like we're going to run out of time and not get to question 6. Try it on your own and then answer the question or look at the answer on the answer key and see how you do.